Greetings, fellow nerds. I want to make some glow sticks for Halloween, and to do that I needed some oxalic chloride. Now I already had some from years ago when I made my first glow stick video, so I went to the back of the lab to retrieve it. And this is what I found. This is pretty nasty. I suspected something like this might happen, so I stored it in a separate container like this. Normally I wouldn't show a failure like this, but this one is actually interesting. If nothing, for the glimpse into the dirtier side of chemistry. Let me remove this foam padding. Oh, that is pretty bad. The secondary containers for each chemical are severely corroded. On the left, I think is triethylamine, while on the right should be oxalic chloride. I haven't touched this thing for years. I stuffed paper and aluminum foil in here to react with any escaping chemicals and render them less harmful. Looks like the aluminum foil was completely and totally destroyed. There is no trace of it left. Let's see if I can get the oxalic chloride. Wait a minute. What the? The oxalic chloride must have leaked out and reacted with the air to form hydrogen chloride that ate through the steel lid. Good thing I'm doing this in my fume hood. Okay, let's see what we got here. Doesn't seem to be any cracks. Let me get the bottle. Okay, there's the problem. The cap is cracked. That's how the volatile oxalic chloride got out. Now I remember 5 years ago when I packed this that the cap was fine. It must have decayed from old age. The bottle seems empty. All the oxalic chloride has escaped. In case you're wondering, the strange surface on the bottle is actually a plastic coating. It was placed there by the manufacturer to protect the bottle from breaking and to contain the glass should it break. The coating has now delaminated from the bottle from sitting for years. I'm sure the exposure to oxalic chloride didn't help matters. Okay, so the oxalic chloride is a total loss. Let's check the triethylamine. Okay, the lid is still solid and hasn't rusted off. Let me get it out of there. Not easy to open. This white powder is likely triethylamine hydrochloride, so it might be leaking too. Okay, I am not able to open this. I'll have to smash it out later. Let's check on the contents. Okay, this definitely is triethylamine. There doesn't seem to be any obvious leaking. Wait, it's hard to see, but there is some fluid in there. I might still have some triethylamine left. I wonder why it didn't all evaporate away. Either it's not leaking at all and the original white powder is something else, or the continued rusting of the lid sealed it all in. Now, the total loss of oxalic chloride is a major setback. Fortunately, I did purchase some cyanuric chloride a while back, and that can be used to make oxalic chloride. Let me go and get that and check on it. And here we are. Okay, here it is. Wait a minute. What the? Well, this is very bad. Cyanuric chloride actually decomposes on exposure to the moisture in the air to form hydrogen chloride and cyanuric acid. Unfortunately, cyanuric acid and cyanuric chloride are both white powders and impossible to tell apart visually. Nonetheless, I'll have to save it and run some tests. Maybe even attempt to purify it. First, I'm going to need some new containers. These are borosilicate jars with Teflon-lined lids. These are extremely chemically resistant and are immune to most corrosion and decomposition problems, unlike my previous containers. Unfortunately, they are also expensive, so I can't afford to put all my chemicals in them. Nonetheless, I'll keep the cyanuric chloride of unknown quality in them for now until I can confirm its purity. Then I'll move them to more permanent storage. It's imperative I minimize further exposure to air. You're probably wondering why I'm using 2 jars. The first jar is for the material at the top of the container, which is likely most contaminated, not just with cyanuric acid, but also with pieces of the destroyed container lid. The second jar is for the rest of the material, which should be less contaminated. Okay, there we go. Now any good chemist labels their stuff. Until I run more testing, the quality of this chemical is questionable. Still, this is a major and expensive setback. Yet another one of my epic failures that makes this channel so costly to run. The oxalyl chloride combined with its hazardous material shipping fee is not cheap. I'm not sure if I'll be able to make glow sticks in time for Halloween because of this. Anyway, I'm going to clean up the rest of this mess. Thanks for watching everyone. I hope you enjoyed a glimpse into the crap that chemists deal with.